Hi folks, welcome back to Physics with Captain Rod. What we're going to do in this video here is I'm going to talk a little bit about how to calculate the center of area between two curves. And I'm going to point out that we're going to use that to determine the center of mass of, say, an object that was defined by this area here. Now, one thing I'd like to point out is this. The center of mass and center of area are not necessarily the same thing. Well, in fact, they're not the same thing. But if you have a geometry where the mass is uniformly distributed, then the center of mass and the center of area are in the same location. So what that means is you can calculate the center of area and the center of mass will be at that location. So what we're going to do here is we're going to consider this area bound between y equals x squared and y equals minus x out to x equals 4. So that's this stuff right in here. And what we're going to do is we're going to calculate the center of area of that geometry. Now, the center of area is going to have two coordinates. It's going to have an x bar and a y bar. And these are averages. And they're averages of areas. And what you need to do is you need to break this problem up into a bunch of little rectangles. So I'm going to go ahead and just draw one single rectangle that looks like this. Whoops, except it should be vertical. It's the same rectangle you would use if you were going to try to calculate the area bound between these two curves. The width of the rectangle, right, is, I'm going to call that dx. I'm going to imagine that the rectangle is infinitely thin. And now the length of the rectangle is also going to be a factor that I'm sure we're going to need. So the length of the rectangle is this dimension, like this, right? So that length is a function of x. You'll notice as my rectangle goes left to right, it gets longer and longer and longer. And it's equal to x squared plus x. Here's where I'm getting that from. You take the top distance, right, here to here, and subtract the lower distance here to here. Whenever you take the top curve minus the bottom curve, that gets you the length of that vertical rectangle bound between them. All right. So now what we're going to do, right, is we're going to average the x coordinates of each of these rectangles. I guess I'll just leave this in red. So if I take x, and what I need to do now is I need to assign a weight to it. So what I'm going to do is I'm going to multiply by the area of the rectangle, which is length times width. So that's going to equal x squared plus x times dx. So again, this is what we're averaging. This gives it a weight. Then these get added up from 0 to 4. Now, the next thing we need to do is divide out the total area. So the area is going to be the integral, let's see, of length, which is x squared plus x times dx. Right, that's length times width. And again, that is going to be integrated from 0 to 4. So by time we take the top integral and then divide by the bottom integral, we're going to get x bar. And I haven't worked out what that is, and the techniques for integration are not important for the video here. This video was about how to set up the integrals for calculating these. So I'm going to leave that as an exercise to the reader. I'm just going to move on here and talk about how to set up the integral for y bar. So let's get rid of this. I think what I'm going to do here is shrink that down and move it out of the way here. And let's use a different color for y bar. Let's use blue. All right, so y bar is going to be quite a bit different. And I guess what I should have mentioned, and I didn't do this before setting this up, is that our rectangle here has a center in its geometric center. Now, the way I drew it makes it kind of look like it's maybe on the x-axis. It's not. It's some other location. I'm going to put it actually down here a little bit, down below. So the x-coordinate is x, but the y-coordinate is going to be slightly different. You'll notice that's at the midpoint of the rectangles, right? Now, how do you get a midpoint? It's an average. So if I take the two curves and I average their y values, that's going to be x squared plus this, which is minus x. So I'm going to change that to x squared minus x, and then divide by 2. That's going to tell me the y-coordinate of the centroid of these rectangles, anywhere they're at. So let's see, y-coordinate, then we have to multiply by area. So again, that's going to be the length, x squared plus x, times the width, dx. And then these get added up from 0 to 4. And then we divide out the total area, which again is going to be the integral 0 to 4. Let's see, length times width. And again, I'm going to leave it as an exercise to the reader to work this out and see what you get. But you're going to get a pair of numbers for x bar and for y bar. And what they're going to tell us is, and let me change colors here, they're going to give us a location somewhere within this geometry. And I'm just going to put a cross here, and let's say it ends up being right there. And that location is the location where you could put a force vector, a gravitational force vector, to represent the weight of this geometry. All right, so that's probably enough on this this video here. Again, the attention was to how to set up an integral to calculate a center of area, and to mention the fact that you can use that as the center of mass if the mass is uniformly distributed. And I hope that this has helped. Have a great day.